So in this latest video looking at trigonometry, we'll be focusing on how to work out the exact values of trig ratios of 30 degrees, 45 degrees and 60 degrees of both tan, sine and cos. Now, although trigonometry is most likely to appear on a calculator topic, there are certain values that you need to know that could easily appear on the non-calculator paper. And this is a very relatively new foundation topic, so you tend to find that these questions are now becoming more and more popular when it comes to GCSE exams. Now, in order to understand the following, you must be confident in 1. Work using trigonometry to find missing sides on right angle triangles, 2. Using trigonometry to find missing angles on right angle triangles, and 3. Using Pythagoras to find missing sides on right angle triangles. Now, if you're not too sure on these 3 things, then I strongly recommend you stop watching this video and have a look at the videos which I'll include in the link on these 3 areas. Now, there are 9 values of trig ratios that you need to learn. So therefore they are the cos, sine, tan of angles 30 degrees, 45 degrees and 60 degrees. Now, even at A level, there is going to be expectations of you knowing these values off by heart, or the exact values of these values off by heart. And there are certain techniques that you can learn to memorize these values. Alternately, you can revise these values as if it was a spelling test. However, what I'm going to do is I'm going to go through one method of how we can actually work out what these values are. Now, how these questions are usually presented on the foundation paper, they're usually multiple choice. So is this a really important topic? At foundation level, probably not. It's only going to be worth generally 1 mark, and it is going to be multiple choice. Now, from all the questions that I've looked at from past exam papers, the answer usually is the one that's most complicated. So the one that's got the square root is often the answer. However, that is not going to be for certain. But if you're going to have an educated guess, I would strongly opt for going for the one that looks more complicated. But if you can memorize these 9 values, then all the better. Now, another alternative you could get to the foundation paper is questions like you can see underneath. So for example, here we need to work out what cos 60 plus cos sine 30 is plus 4 tan 45 is. So looking at these individual values, I know that cos 60 is a half. So that's going to be a half. Plus sine 30, which is also a half. Plus 4 tan 45, well tan 45 is 1, so I'm going to add 4 times 1 to work this out. Now, working these out from that, I've got a half plus a half, which is 1, so that's going to add up to 1. So I've got 1 plus 4 times 1, which is 4, which gives me a final answer of 5. Here I've got cos 30, so let's just get rid of these bubbles. So here I've got cos 30, which is root 3 over 2, so that equals root 3 over 2, plus sine 60, which is another root 3 over 2, which gives me, and if I work that out, that's going to give me 2. I don't know why I've put a plus sign there. Let's give that 2 as well. So here what I've got is I've then got 2 root 3 over 2, because when you're adding fractions and denominators the same, I just add the top 2 numbers. So root 3 plus root 3 gives me 2 root 3. And then from this, the 2 2's cancel, in which all I'm left with is root 3. So here is an example of a type of question that you could get to work out, and using these trig ratios in a more different way of how this question could be presented in your exam paper. So let's now have a look at how we generate these 9 values. So as I said, one way is to recognize or memorize those values just like you would with a spelling test. Another way is to see how these are created. So let's just take as an example a isosceles triangle, a right angle triangle, where the 2 angles are going to be 45, 45, and the horizontal length, the base and the height of this right angle triangle has got a length of 1. Now, using Pythagoras, so using Pythagoras is, I know that if I call this A and B, I know that A squared, and this is going to be side C, because opposite the right angle, so A squared plus B squared equals C squared. So what I'm going to end up with is 1 squared plus 1 squared equals C squared. So 2 equals C squared, so C equals the square root of 2. So if I just get rid of all of this, I've now calculated that this length here is going to be root 2. So what I've got is I've now got all three lengths of my triangle. Now from this, what I'm going to do is going to just get rid of this top angle of 45. I don't really need it. So let me just get rid of that 45. So we're just focusing on this one. Now what we're going to do is incorporate trig. So this 45 degrees is my theta. So therefore the root 2 is my hypotenuse. This is going to be my opposite. And this base is going to be my A. So now using our trig ratios, which if I just write down what the trig ratios are, so I've got tan theta equals opposite over adjacent. I've got sine theta, which equals opposite over hypotenuse, and cos theta, which is adjacent over hypotenuse. So now what I'm going to do is I'm going to use these values. So I know that O equals 1, H equals root 2, and A equals 1. So what I'm going to do is I'm going to substitute these numbers into this formula. And I also know that theta equals 45. So using this trig ratio, I've got tan 45 equals, and that's going to be opposite over adjacent, which is 1, divided by 1, which is 1. Don't know why I've put L, so let's just change that to a 1. So then if I look at sine 45, well, sine is using opposite over hypotenuse, so I've got 1 over root 2. So that equals 1 over root 2. And then I've got cos theta equals adjacent over hypotenuse, which is 1 over root 2. So that's 1 over square root of 2. Now, what you will then find is that these values, those three values that I've got here, are, if I just scroll back up, these middle values here. And so that's how I've generated those three numbers. So as long as you remember that I've got an isosceles triangle with the base and the height of 1, the hypotenuse is 2, I can then work out what those values are without having to remember the trig ratios. However, you want to be able to do this relatively quite quickly. So now let's have a look at how the 30 and 60 ratios are generated. So if we took an equilateral triangle with lengths of 2, then you can see I've got three sides which are the same. And the interior angles are all going to be 60. So I've got length of 2, 2, 2. Now if I then go on to halve this triangle, so actually let me use a different colour. So let's go for blue. So if I was to divide this triangle into 2, then this length here would be 1. This angle here would remain 60. However, this angle here, if I just get rid of that angle there, this angle here would actually be 30 degrees. So what I'm going to do is I'm going to take this triangle. So if I just highlight this triangle in yellow, so if I cut that triangle out, what I get is something that looks like this triangle here. So here I know what this base is, I know what this length here is, and this angle here is 60, and this angle here is 30. So now what I can do is I can use Pythagoras to work out what the height of this triangle is going to be. So again, using Pythagoras, labeling my triangle, so this is going to be C because it's opposite the 90 degrees. I'm going to call this A and I'm going to call this B. So here I've got A squared plus B squared equals C squared. So I've got A squared plus 1 squared equals 2 squared. So from this, what I've got is I've got A squared plus 1 equals 4. So A squared equals 3. So A is going to equal the square root of 3. So what I can now do is I can get rid of my A, B, C values, and I've now worked out what the three lengths of that triangle is going to be. So what I've got is I've got one length is root 3, the base is 1, and the hypotenuse is going to be 2. So now taking this particular triangle, which I'm just going to looking at this one here, what I end up is with something that looks like this. Now this here is now root 3, which I've already worked out. Now taking this angle of 60 degrees, if I then go on to label this triangle again, so here I've got this is my H, this is my O, and this is my A. So labeling these, I've got A equals 1, O, which is root 3, and H, which is 2, and theta is 60 degrees. And again, looking at the trig ratios, I've got tan theta, which is O over A, sine theta, which is O over H, and cos theta, which is A over H. So now substituting these numbers into those formulas or the trig ratios of these here, what I end up is with tan 60 equals root 3 over 1, which is just root 3. I've got sine 60, which is opposite over hypotenuse, so that's going to be root 3 over 2. And I've got cos 60, which is adjacent over hypotenuse, so I've got 1 over 2. So here are my next three values of those. And if I scroll back up to my table, you can see that's where I've got these three values from. So now if I take the same triangle, so here I had my triangle here, this time what I'm going to do is I'm going to focus on this 30-degree angle. So if I take the same triangle, and this is what I end up with, so this angle here is the 30, this one here is going to be the 60, but again I'm not going to focus on that one because I need to focus on one. And this side here we've already worked out is root 3, so I've just kind of rotated that triangle. So looking at this now, what I've got is I've got that the hypotenuse is H, which is 2, sorry. I've got the opposite, which is 1, and the adjacent, which is root 3. So here I've got H equals 2, O equals 1, A equals root 3, and I've now got theta as being 30 degrees. So from this, what I can then do is, again, recording my trig ratios of O over H, sine theta, which is opposite over hypotenuse, and cos theta, which is adjacent over hypotenuse. So from this, I'm just going to substitute the numbers in, or sub these values into that formula. So I've got tan 30 equals opposite over hypotenuse, which is just going to be 1 over root 3. I've got sine theta, or sine 30 should I say, which is going to be opposite over hypotenuse, so I've got 1 over 2, and then I've got cos 30, which is adjacent over hypotenuse, and the adjacent is root 3, hypotenuse is 2. So lo and behold, I've got my three values here, which if I go back to my table, are these three values here. So you can see here that by remembering those two triangles, you can actually physically work out what those angles are, but this actually shows you where those values come from. Now, in terms of offering advice, personally, I would try and remember these 9 values as you would do as normal spelling for, let's say, an English exam, or an English test, I should say. So, like I said, depending on what level you are working at, if it's foundation, it's more likely to appear as a multiple choice question. If it's on a higher paper, this is where you could easily get a trig question on a non-calculated paper, and where you would use a calculator, you're more likely going to use the values, or the angle is either going to be 30, 45 and 60, in which you would replace the trig ratio with one of these 9 values to work out what the angle, or that the missing side, is going to be for that particular triangle. Now, we'll put some general notes in the description below, along with another method in which where you can work out the trig ratios by using your hand. And again, I'll include everything in the description below for you to use, as well as a copy of this table for you to print or duplicate in your notes or revision cards.